Hi students, good morning all of you. Hope you are all doing good. Welcome to 43rd lecture in this course. At present we are discussing definite integrals unit and today's topic is area under the curves. In this lecture we will be solving some problems on finding areas using definite integrals. Before getting into the problems, let me explain the steps involved in finding areas using definite integrals. Here is the first point. Plot the graphs of all the functions given in the problem and identify the required area that is being asked in the problem. The third step is find the point of intersections if at all required. And the last and final point is apply the appropriate result to write the integral for finding the area. Here is the first problem in this lecture. Find the area enclosed by the curves y is equal to x square, y is equal to 2x. If I plot these two graphs, then I will be getting this graph. The parabola y is equal to x square is represented in the orange color curve, and that of y is equal to 2x is a line passing through the origin, and it is given by the magenta color line here. So what is the required region? So the area must be enclosed by these two curves. So this is the required area that we need to find out, because this is the only part which is covered by both the curves. Okay, now the shaded region is shown in the green color, so we have to find out the green color region. So before that I need to find out these two point of intersections. To find out the point of intersections, I need to solve these two equations. So let me solve these two equations. So how will you solve? Y is equal to x square and y is equal to 2x are the two curves that are being given. Now I have to equate these two in order to get that. So x square is equal to 2x. So x into x minus 2 is equal to 0. This is x is equal to 0 comma x is equal to 2. So you can see that in the second graph they are indicated, the point of intersections are 0 comma 0 and 2 comma 4 here. Okay, now let me set up an integral to find out the area that is being asked in the problem. Yeah, so the required area is equal to integral. So which result we are going to apply? I think we are going to apply the sixth result. Okay, so it is from integral 0 to 1. The upper curve here is 2x minus the lower curve here is x square into dx. Okay, that is equal to, so let me integrate this. So this is equal to 2 into x square by 2 minus x cube by 3. So apply the limits, upper limit, sorry, I think the limits are 0 to 2. So it is 0 to 2, that is equal to x square minus x cube by 3. Upper limit is 2 and the lower limit is 0. So after applying it, what do we get? 2 square minus 0 square minus, it is 1 by 3 into 2 cube minus 0 cube. So area A is equal to 2 square is 4 minus 2 cube is 8 by 3. So this is equal to 4 by 3. So area of the required region is, area of the required region is 4 by 3 square units. Okay, let us solve the next problem. Here is the next problem. Find the area enclosed by the curves y is equal to x square and y is equal to x cube. We know both these graphs, y is equal to x square and y is equal to x cube. So This is the diagram for that. So the red color curve is y is equal to x cube, and that of blue color curve is y is equal to x square. So here they have given mistake here. So this is y is equal to x cube. Yeah. Now we have to find out the area enclosed by these two curves, and you can see that in the entire picture this is the only region that is being enclosed by both the curves. Okay, so here I will show you the shaded region. Yeah, the shaded region is the required region is shaded in yellow color. Okay, that is the area that we need to find out. So before that we need to find out the point of intersections. So let me solve these two equations. Y is equal to x square and y is equal to x cube or the two given curves. To find out the point of intersections, I need to equate both these equations. X cube is equal to x square, that is x square, if I take common, this becomes x is equal to 1. So this implies the roots are x is equal to 0 comma x is equal to 1. So these 2 points, the point of intersection are indicated here, 0 comma 0 and 1 comma 1. So the point of intersections are 0 comma 0 and 1 comma 1. Now let me set up the integral to find out the area of the required region. So area A is equal to integral 0 to 1. So integral 0 to 1, the upper curve here is in the region 0 to 1. The x square curve is dominating. So x square is the upper curve and x cube curve is the lower curve. So x square minus x cube into dx. So x square integration is x cube by 3 minus x cube integration is x to the power 4 by 4. I have to apply the upper limit and lower limit, that is 1 by 3 into 1 cube minus 0 cube minus 1 by 4 into 1 cube minus 0. So that is equal to 1 by 3 minus 1 by 4. So A is equal to 1 by 3 minus 1 by 4. The LCM is 12. So it is 4 minus 3, that is 1 by 12. So the area of the required region is 1 by 12 square units. Okay, hope you have understood this problem. Let us solve the next problem. Here is the next problem. Find the area of the region enclosed by the curves y is equal to cos x and y is equal to 1 minus 2x by pi. So anyway we know the curve cos x, y is equal to cos x graph you know, and y is equal to 1 minus 2x by pi. 2x by pi, 1 minus 2x by pi, it's a straight line. Okay, so you convert this into the intercept form and then find out the straight line. Okay, if I plot these two curves, this is how the graph looks like. You can identify that the red color curve is our straight line, y is equal to 1 minus 2x pi, and the blue color curve is y is equal to cos x. Now I have to find out the area of the region enclosed by both the curves, namely cos x and the straight line y is equal to 1 minus 2x by pi. So identify the region. So this is the region that is enclosed by both the curves. Okay, this is the region. Okay, let me shade it here. So this is the required region that we need to find out. Okay, now let me show you the shaded region. Yes, so you have the required region is shaded in yellow color as well as the green color. Now here you have some point of intersections here. How do we find out the point of intersections? So we have to find out the point of intersections here. Finding the point of intersections. You can see that at x is equal to 0, cos x is 1, cos 0 becomes 1, and that of 1 minus 2 into 0 by pi, that is also equal to 1. So both the curves intersect at 0 comma 1. So this is the first point of intersection, 0 comma 1. Now you can see that this is the straight line intersects the x-axis, or the x-intercept of the straight line is pi by 2. So at x is equal to pi by 2, cos pi by 2 becomes 0 anyway, and the straight line also satisfies that. So 1 minus 2 by pi into pi by 2. So that is also equal to 0. So the next point of intersection is pi by 2 comma 0 and the curve intersects the curves at one more place, namely here. This could be at x is equal to pi. Cos pi value is what? Cos pi value is minus 1, and that of this value is 1 minus 2 by pi into pi. So that is equal to 1 minus 2, that is equal to minus 1. So both the curves match at the point pi. So this is another point of intersection, namely pi comma minus 1. So the required area is divided into two parts, namely the yellow colored shaded region and the green colored shaded region. So the required area is divided into two parts, namely A1 plus A2. Okay, how do we find out A1? So A1 is equal to integral 0 to pi by 2. So what is the upper curve here? It is cos x is the upper curve here. So this is equal to cos x minus the lower curve is y is equal to 1 minus 2x by pi. So this is 1 minus 2x by pi into dx plus the area A2. How will you find out? This is pi by 2 to pi, and in this region the red color curve is the upper curve, that is the straight line is the upper curve. So it is 1 minus 2x by pi minus cos x whole dx. Now let us find out the integration. So first integral, if I compute integration, cos x is sin x minus integral 1 is x plus 2 by pi into x square by 2. So the lower and upper limits are 0 and pi by 2 here, plus the second integration is x minus 2 by pi into x square by 2 minus cos x integration is sin x. So the upper limit and the lower limits are pi and pi by 2 here. Okay, let me write it pi. Okay. Now substitute the upper limit and the lower limit is sine pi by 2 minus sine 0, first function, minus pi by 2 minus 0 plus, that is 1 by pi into x square. So 1 by pi into pi by 2 whole square minus 0 plus pi minus pi by 2 minus 1 by pi into pi square minus pi by 2 whole square minus sin pi minus sin pi by 2 whole bracket. Yes, now I'll write down the values. Sin pi by 2 is 1, 1 minus 0, this becomes 1 minus, this is pi by 2, and this is going to be pi square by 4, so pi gets cancelled, then this becomes pi by 4, okay, plus pi minus pi by 2 is pi by 2 minus pi square minus pi square by 4 is 3 pi by 4, 1 by pi into 3 pi by 1 by pi into 3 pi square by 4, it is 3 pi by 4 minus sin pi value is 0 plus sin pi by 2 is 1. So this is going to be, so this minus pi by 2 and plus pi by 2 gets cancelled, and this is 2 minus pi by 2. So this is equal to 4 minus pi by 2 square units. So the required area A is equal to 4 minus pi by 2 square units. I hope you have understood this problem. Here is our next problem. Find the area enclosed by the curves y is equal to sine 2x and y is equal to root 3 into sine x, and x is equal to 0 and x is equal to pi by 2. Hope you know these two curves, sine 2x and root 3 sine x, we have discussed in these graphical transformations. Let me plot these two graphs, and this is how the graph looks like. Now we have to find out the region enclosed by the two curves, namely sine 2x and root 3 sine x, comma x is equal to 0 and x is equal to pi by 6. So here this is pi by 6 and this is 0 comma 0. So you can see that a narrow strip here which is enclosed by these two curves. This is the region that we need to find out. We need to find out this point of intersection. What is the point of intersection? Let us find out. So y is equal to sine 2x and y is equal to root 3 comma root 3 into sine x are the two curves that are being given. Let us find out the point of intersection. So sine 2x is equal to root 3 into sine x. So let me write this as 2 sine x into cos x minus root 3 into sine x is equal to 0. Now if I take common sine x, this becomes 2 cos x minus root 3, that is equal to 0, implies sin x is equal to 0. Let me write that here. We get sin x is equal to 0 comma 2 cos x minus root 3 is equal to 0 implies cos x is equal to root 3 by 2. So cos x is equal to root 3 by 2 implies x is equal to pi by 6, and x is equal to 0 means x becomes 0. So the point of intersections are x is equal to 0 and x is equal to pi by 6. So these are the two point of intersections are namely x is equal to 0 and x is equal to pi by 6. So let us set up the integral to find out the required region. So area A is equal to integral, so it is from 0 to pi by 6, it is from 0 to pi by 6. Which curve is upper and which curve is lower here? So the red color curve is here is lower curve, and that of blue color curve is upper here. So the area is sine 2x minus root 3 into sin x into dx. Okay, so integral sine 2x is minus cos 2x divided by 2 minus root 3 into integration sin x is minus cos x in the limits 0 comma pi by 6 here. So this becomes minus 1 by 2 into cos 2x plus root 3 into cos x. The lower and upper limits are 0 comma pi by 6. Now substitute the upper and lower limits here. So it is cos 2 pi by 6 minus cos 0 plus root 3 into cos pi by 6 minus cos 0. So that is equal to minus 1 by 2 into cos pi by 3. Cos pi by 3 is 1 by 2 minus cos 0 is 1 plus root 3 into cos pi by 6 is root 3 by 2 minus 1. So that is equal to minus 1 by 4 plus 1 by 2 plus 3 by 2 minus root 3. So that is equal to 1 by 2 plus 3 by 2, that is 2, minus 1 by 4 is 7 by 4 minus root 3. So that is equal to 7 minus 4 root 3 by 4 square units. So the required area is equal to the area of the required region (7 minus 4 root 3 by 4 square units). Hope you have understood this problem. Let us solve the next problem. Here is our next problem. Find the area enclosed by the curves y is equal to 4x minus x square and y is equal to 2x. The first curve is y is equal to 4x minus x square. It's a parabola. You can draw the curve by completing the square and use some graphical transformations, and y is equal to 5 minus 2x is a straight line. So if I plot these two curves, so this is how the graph looks like. The red color curve is the straight line y is equal to 5 minus 2x, and that of blue colored curve is the parabola y is equal to 4x minus x square. Now we have to find out the area enclosed by these two curves. There is no other straight line, there is no other curve that is being given. So obviously our guess could be this is this region. Yes, this is the required region that we need to find out. So here you need to find out the point of intersections. So how do I find out the point of intersections? So let us solve these two curves to find out the point of intersection. So 4x minus x square is equal to 5 minus 2x. So that is equal to x square minus 6x plus 5 is equal to 0. So this is x minus 1 into x minus 5 is equal to 0. So the x values there are 1 comma 5. So you can see that at 1 exactly, so this is 1 comma 4 into 1, that is 4 minus 1, so this should be 4 comma 3, and this should be 5 comma, it is some negative value, so 5 minus 10, that is minus 5. So let me show you the shaded region here. This is the shaded region. So 1 comma 3 comma and 5 comma minus 5 are the point of intersections. So we need to find out the required region which is shaded in yellow color. Let us set up the integral. So the integral area is equal to, so we have to start from 1 to 5. Integral limits are, the limits are integral from 1 to 5. What is the upper curve here? It is a 4x minus x square, 4x minus x square, and that of lower curve is y is equal to 5 minus 2x. This is straight line. So 5 minus 2x straight line. Okay, let me simplify this. So integral 1 to 5, 4x minus x square plus 2. So this is minus x square, 4x plus 2x is 6x minus 5 into dx. So if I integrate it, then this becomes minus x cube by 3 plus 6 into x square by 2 minus 5x. The lower limit is 1 and that of upper limit is 5. So let me evaluate the integrand at upper limit and the lower limits. So 1 by 3 into 5 cube minus 1 cube plus 3 into 5 square minus 1 square minus 5 into 5 minus 1. So this is minus 1 by 3 into, this is 124 plus 3 into 24 minus 20. So this is equal to, so minus 124 by 3 plus 72 minus 20 is 52. Yeah. So that is equal to 52 into 3. So it is minus 124 plus 52 into 3 is 156 divided by 3. So the required area is plus 6, 30 plus 26. So it is 32 by 3 square units. So the required area is is 32 by 3 square units. Yeah. Hope you have understood this problem. Let us solve the next problem. Here is our next problem. Find the area enclosed by the two curves, namely y is equal to x square minus x minus 1 and y is equal to minus 1. So the second curve, y is equal to minus 1. You have two curves, namely y is equal to x square, y is equal to x square minus x minus 1 and y is equal to minus 1. Y is equal to minus 1 is a horizontal straight line and y is equal to x square minus x minus 1 is a parabola. Okay, and by completing the square you can find out the parabola and you use the appropriate graphical transformations to draw that. So if I plot these two curves, this is how the diagram looks like. Okay, so the blue colored curve is y is equal to x square minus x minus 1, the parabola, and the red color one is y is equal to minus 1 straight line. Now I have to find out the area enclosed by these two curves. So obviously you can see that this is the region that we need to find out. Now the line y is equal to minus 1 is intersecting the parabola at 2 points. This is what we have to find out. So let me solve the point of intersections. To find out the point of intersection, so we have to equate both the curves. So x square minus x minus 1 is equal to minus 1. So this becomes x square minus x is equal to 0. That is x into x minus 1 is equal to 0 implies x is equal to 0 comma 1. So x is equal to 0. At x is equal to 0 and at x is equal to 1, the straight line and the parabola intersects. So the 2 points are, so this is 0 comma, if I substitute 0 here, 0 0 comma minus 1, so it is 0 comma minus 1 and this will be 1 comma minus 1. I will show you the shaded region. Shaded region is yellow color shaded region. Okay, the required region is shaded in yellow color. That is what we need to find out. Okay, let us compute the integral here. Let us set up an integral to find out that area. So it is the integral. Okay, so here the limits are from 0 to 1. The x limits are from 0 to 1. So in this region, what is the upper curve and what is the lower curve? The upper curve is y is equal to minus 1 straight line. So minus 1 straight line minus the lower curve is the parabola x square minus x minus 1 is equal to dx. So it is integral 0 to 1 minus 1 minus x square plus x plus 1 dx. So that is equal to integral 0 to 1 and minus 1 gets cancelled. This becomes x minus x square dx. So integral x is x square by 2 minus integral x square is x cube by 3. So upper limit and lower limits are 1 comma 0 here. So area is equal to, this is 1 by 2 minus 1 by 3. So that is equal to 1 by 6. So the area of the required region is area of the required region is 1 by 6 square units. Okay, Hope you have understood this problem. Let us solve the next problem here. Here is our next problem. Find the area enclosed by the curves y is equal to x square plus 1, y is equal to 2x minus 2, x is equal to minus 1 and x is equal to 2. You know that y is equal to x square plus 1 is a parabola and y is equal to 2x minus 2 is a straight line. Of course you can plot that. X is equal to minus 1 is a vertical straight line and x is equal to 2 is again a vertical straight line. Now if I plot these four graphs, this is how the graph looks like. So this is the line x is equal to minus 1 and this is the line x is equal to 2 and this is the straight line y is equal to 2x minus 2 and the blue color curve is y is equal to x square plus 1. Now we have to find out the region enclosed by these four curves, and obviously you can see that this is the area that is enclosed by all the four curves. So I am shading this region which we need to find out. Okay, so I think these two curves are not intersecting at any point. Okay, so how to know whether these 2 points are not intersecting or not? Let me equate this. If at all they intersect, what happens? So x square plus 1 is equal to 2x minus 2. Okay, so it is x square minus 2x minus 3 is equal to 0. Let me find out the discriminant here. Discriminant is what? B square minus 4ac minus 2 whole square minus 4 into a into c. So it is 1 into minus 3. I think this is plus 3. So this is here, it is x square minus 2x, it is plus 3. So discriminant is going to be minus 2 whole square minus 4 into 1 into 3. So that is equal to 4 minus 12, that is equal to minus 8, which is negative. So this equation has complex roots. Complex roots means there is no intersection. Okay, so no intersection. That's why in the diagram also these two curves are not intersecting. Let me show you the required region. The required region is shaded in yellow color. So this is the region that we need to find out. So the required region A is equal to integral. So the limits are from minus 1 to 2. And here the upper curve is x square plus 1. The upper curve is x square plus 1 and that of the lower curve is 2x minus 2 dx. So that is equal to integral minus 1 to 2 integral x square plus 1. Let me simplify this. So this is x square minus 2x plus 1 plus 2 is plus 3 dx. So integration x square is x cube by 3 minus 2 into x square by 2 plus 3x minus 1 to 2, the lower limit and the upper limit. So this is equal to 1 by 3 into 2 cube minus of minus 1 cube minus 2 gets cancelled here. x square means 2 square minus of minus 1 whole square plus 3 into 2 minus of minus 1. So that is equal to 1 by 3 into 2 cube is 8, 8 plus 1 9 minus 2 square is 4 minus 1 plus 3 into 3. So 9 by 3 is 3 minus 3 plus 9. So that is equal to 9. So area is equal to 9 square units. So the area of the required region is 9 square units here. Hope you have understood this problem. Let me solve the next problem. Here is our next problem. We need to find out the area of one of the curvilinear triangles bounded by the curves y is equal to sin x, y is equal to cos x, and that of x-axis. Okay, plotting these two curves on the coordinate axis will give me this figure. So let me identify the curvilinear triangle here. So if you look at this triangle, of course this looks like a triangle. Now x-axis is missing here. Both the curves cos x and sin x are present, but x-axis is missing, so this is rejected. Now if you look at this portion of the curve, this portion of the graph, this looks like a triangle, and it meets our requirement also. One of the edge of the triangle, or one of the sides of the triangle, is x-axis, and other side is this orange color curve is a sin x curve, and that of cos x curve. So this is the required area that we need to find out. Okay, now you need to find out this point of intersection also. Of course, you know sin x and cos x intersect at pi by 4 in the first quadrant, so it is pi by 4 comma 1 by root 2. Now this is the area that we need to find out. So how do I find out this area? And if you observe this area carefully, the entire area is not under the same curve. Till one point it is under the curve sin x, and from that another point to the last point here, okay, it is the area is under the curve cos x. If you let me tell you clearly, so this is the point, let us say it is pi by 4, let us say it is pi by 4, and this will be pi by 2, because the cos curve intersect the x-axis at pi by 2 comma 0. So in order to find the entire area is not under the same curve. So 0 to pi by 4 it is under the sine curve, and from pi by 4 to pi by 2 it is under the cos curve. Okay, let me show you another picture. Okay, so this is the required area that we need to find out. Okay, this entire area is splitted into two parts. Okay, one is a1 and other is a2. So a1 is under the curve sin x, and that of a2 is under the curve cos x. Okay, so this is the point 0 to pi by 4, and it is pi by 2. So let me denote this as point A, and this is point B. Now area of the triangle, let us find out. Area of this curvilinear triangle, let us find out. Solution. So the entire area is splitted into two parts, namely a1 and a2. So a1 plus a2. The first integral is integral 0 to pi by 4. So it is an orange color curve. Orange color curve is the sin x. So this is sin x dx. Now the second integral is from pi by 4 to pi by 2, and it is under the curve cos x into dx, right. Now integration sin x is minus cos x. The limits are 0 to pi by 4, plus integration cos x is sin x, and the limits are pi by 4 to pi by 2. So that is equal to minus cos pi by 4 minus cos 0 plus sin pi by 2 minus sin pi by 4. So if you write down these values, so this is minus 1 by root 2 minus 1 plus 1 minus 1 by root 2. So that is equal to 1 minus 1 by root 2 plus 1 minus 1 by root 2. So that is equal to 2 minus 2 by root 2. That is equal to 2 minus root 2. So the area of the triangle, curvilinear triangle OAB is 2 minus root 2 square units. Hope you have understood this problem. Let us solve the next problem here. Here is our next problem. Find the area enclosed by the curves y is equal to 2 minus x square and y is equal to x square. So y is equal to 2 minus x square is a parabola that we have discussed in the graphical transformations lecture, and y is equal to x square is also a parabola. So plotting these two parabolas on the coordinate axis will give me this figure. The red color curve is y is equal to x square curve, and that of blue color curve is y is equal to 2 minus x square curve. These two curves intersect at some points. Now let us see what is the region that we need to find out. So area should be enclosed by both these curves. Now if you look at the figure, this is the only portion that we need to find out. So this is the area, this entire portion. Okay, this entire portion we need to find out. Okay, now to find out the region, we need to find out these point of intersections. To find out these point of intersections, we need to solve these two equations. Let me solve these two equations. It is 2 minus x square is equal to x square. So this is 2x square is equal to 2 and x square is equal to 1 implies x is equal to plus or minus 1. So this is minus 1. So this is minus 1 comma. So if I substitute 1 here, this is going to be 1 minus 1 comma 1. This is 1 comma 1. Okay, so how do we go about finding the area? So let us find out the area. Solution here. Area A is equal to, okay, let me show you the shaded region here. Here is the shaded region. The required region is shaded in yellow part. Okay, now let us find out the area of the required region. Area is equal to minus 1 to 1. The upper curve here is y is equal to 2 minus x square. 2 minus x square minus that of the lower curve is y is equal to x square. That is equal to, so it is minus 1 to 1, 2 minus 2x square dx. Now if you observe this integrand, 2 minus 2x square is an even function. It is symmetric about y-axis. So this can be written as 2 into integral 0 to 1 2 minus 2x square. So we are using a result of definite integrals here to simplify this integral. So reason here is 2 minus 2x square is an even function. Yeah. So that is equal to 2 into, if I integrate this integrand, it is 2x minus 2 into x cubed by 3. So the limits are from 0 to 1 now. So that is equal to 2 into 1 minus 0 minus 2 by 3 into 1 cube minus 0 cube. So that is equal to 2 into 2 minus 2 by 3. So it is 2 into, this is 6 minus 2, that is 4 by 3. So that is equal to 8 by 3. So the area of the required region A is equal to 8 by 3 square units. Hope you have understood this problem. Let me solve the next problem. Okay, before solving the next problem, let me explain this even function part. So we have written this portion, this area is equal to 2 times this integral. Okay, what does this mean? Okay, graphically what does this mean? So this in the graph, so this, if I split it into two parts, namely a1 into a2, because this curve, these two curves are symmetric about the y-axis, the area a1 is equal to area a2. That means we are finding actually this area first. So if you find out a2, let me compute a2. So a2 is equal to what? a2 is equal to integral 0 to 1, this upper curve is 2 minus x square, and that of the lower curve is minus x square into dx. So that is equal to integral 0 to 1, 2 minus 2x square. Of course we have found out this integral, so this is equal to 4 by 3. Okay, so since a is equal to a1 plus a2, and we know that a1 is equal to a2 because of the symmetric property, so a2, that is equal to 2a2. 2a2 is equal to 2 into 4 by 3, that is equal to 8 by 3. So this is the geometric meaning of this integral. Minus 1 to 1, 2 minus a even function is equal to 2 times this integral. So I hope you have understood that particular result graphically also. Okay, let me